You have a chessboard. Do you know this game?
Yeah.
How many squares are on a chessboard?
64.
64. Yeah. And you put one grain of wheat on the first square, you put 2 on the second square, you put 4 on the third square, you plus 8 on the next square, and so on. Can you picture this? So you put 1, then you put 2, then you put 4, then you put 8. And you go around the board like this. So the question is, how much is there altogether? Yeah. Do you understand what's happening? Yeah. So, how much is on the first square? 2.
It's not working.
Okay. How much is on the second square? 4. It'll just be a second. The next square? 8, and then 16, and so on. Right, so what is the A here? 2, and the R? 2, and the N? 64. AP or GP? GP. So you want sum 64. Yep. A 1 minus or N over 1 minus or. Oh, 1 on the first, okay. Okay, just to make a small change here, it was 1 on the first square, 2, 4, and then 8. So the only thing that changes here is the A is 1. So it's 1 minus 264 over 1 minus 2, which equals 264 minus 1, when you simplify it. But you can leave it like this because it's a really big number. Maybe surprisingly big. You look confused. Yes? What's confusing you? The whole question, is it?
No, like 1, 2, 4, 8.
So what's happening here, they put 1 on the first square, then they put 2 on the next square, then they put 4 on the next square, then they put 8 on the next square, and they go around the board like this. Yeah. And there's 64 squares because a chessboard is 8 by 8 squares. So there's 64 squares. Yeah. Is that okay?
Yeah.
Yeah. Is there anything else from this page since I'm on it? Because the test is tomorrow, so it will include this page as well. You see, I'm worried people are nodding saying it's okay, because it shouldn't have been okay, because there's some difficult questions there. So the fact that people are nodding here saying, yeah, totally fine, Stephen, worries me a little bit. So is it totally fine?
Yeah.
Oh, okay, as you wish, as you wish. Including number 9. Did people do these during the break, or did everybody clock off for 7 days and watch Netflix and play World of Warcraft or something? No?
Is it okay if we use lots in number 5?
Yes. Yeah. It's okay if you do. Alright. We'll go on to page 50, so. Okay. Exponential equations. I'm just missing Nina, isn't it? Do you know where she is? Was she there? Is she in school this morning, or GNIB the whole day?
No, this morning
She came for the test.
Yeah.
Okay.
Coming back.
much later if it's GNIB. Okay. So for this lesson, there's no new formulas. We're just going to look at using the rules. We turn the light off actually, yeah. We'll just look at using the rules for powers to solve problems. So I'll do some examples. So for example, something like this. 2 power x minus 1 equals 8 power minus x minus 3. So like normal, we want to find the x. Now, it's not important for this lesson. It's more important for the next lesson. But it is good to think about, could x be any number? So when you look at this equation, is there any number x can't be? And the answer is no. X could be any number. There's no problem here with the x. X could be any real number. Now this isn't always true. You know, if you had something like this, I don't know. Could x be any number? No, it could be any number except 0. So the reason I'm telling you this is because if we get more than one answer, then probably both answers are okay. We don't have to worry about rejecting one of the answers. Okay, so any ideas on what we could do first to try and simplify this? Any ideas? Without using logs, not necessary to use logs.
Two.
Substitute, 1 sec. Yeah, okay, you first. Separate how? Oh, I see, with the powers here. Split them out, yeah. And you were saying?
It might be 8 power.
2 power 3.
Yeah.
So both. Yeah, so it doesn't matter which way we do it first. So we could change the 8 into 2 cubed, or we could separate them out. I'll change the 8 into 2 cubed because that's what I feel like doing today. So this will be 2 cubed power minus x minus 3. Now, because I have 2 powers here, I could multiply as well. So I can change this into 2 power minus 3x plus 9. And if I have it like this, I don't have to separate it. So I could leave it like this, and then what would be the next step? Oh, how did that happen? 2x, minus 3x minus 9. Yeah? What would be the next step?
Log.
No need for logs. This is log free. Compare.
But it equals x minus 1 equals minus 9.
Yeah, I think everybody has the idea that if you have 2 power a equals 2 power b, then the a and the b must be the same. So you can say that x minus 1 must be the same as minus 3x minus 9. So you can get 4x equals minus 8. Yeah, so then that means x must equal minus 2. And minus 2 won't be a problem. We can use minus 2. So this is one way to do it. Now this only works because you can change the 8 into 2 cubed. If I was to change the 8 to 9, now we can't do it this way, but we can do it another way, which we'll see later. Okay. Alright, so write this one down. This is our first example of solving an equation with x in the power. Okay. Got this? Not yet.
Okay.
Yeah? Okay. So let's have a look at another type now. So for example, we have 3 power 5x minus 6 equals square root 81 2x plus 6. Right. What about the x? Could we use any value of x, or are there any problems? What do we think? It's okay? Yeah, any value of x will work here. There's not going to be a problem. So for me, the first thing I'm going to do is I'm going to change that square root into power. So square root is power a half. And what about the next thing? What do you think? Well, maybe the next thing I'll do actually is I'll multiply the half in here. So you get 3 power 5x minus 6 equals 81 power 1x plus 3. Because this is the fourth rule of powers, the powers multiply when you have two powers. What's next? What do you think?
81.
Yep. 81 is 3 power 4. Yep. Same deal again. Compare. So you get 5x minus 6 equals 4x plus 12. So you get x equals 18. Okay, write this down. This is our second example. So far, our two examples have only one answer. The next type we'll look at now, things will start to change. Got this? Got this? Yeah? Okay. So let's have a look at the next example now. Nine power x minus 82 times 3 power x plus 81 equals 0. Now things are a little bit more difficult here. We can't really compare anymore because we have three terms instead of two terms. So for example, if this 81, if this wasn't here, maybe I can just take this over to the right and then compare again. Can't do that here. So does anyone have an idea about what we can maybe do to simplify? Any ideas?
9 by
Which one?
transform 81 in 9 power.
9 squared
Yeah.
by 81, yeah.
Yeah.
What else? Anything else? No? No ideas? No?
And then you add the 9 square and the 9.
Good? But no. In fact, the 81, we can leave it as 81. Even though it looks like we should change it to 9 squared, we can leave it as 81. There's something else to do.
Times 82 times 3.
Times 3?
82 times 3.
Nope. Idea?
Use another number that is 3x squared.
Yes, that's it. So before I do that though, I'll just change the 9 into 3 squared x minus 82 3 power x plus 81 equals 0. But this here is the same as 3 power x squared, because 2 times x is x times 2. Now let me use colours here to make it extra clear what's happening. 3 power x squared minus 82 3 power x plus 81 equals 0. Looks familiar? What does it look like? Looks like a quadratic, doesn't it? It looks like x squared minus 82x plus 81 equals 0. Looks, it has the same form. So you could factorize it. What would be the factors here? You would have a minus minus 81 minus 1. And this would be x and x, big X, big X. But it's not big X, what is it? It's 3 power x, isn't it? Equals 0. Now things are looking a lot better, because now you can say 3 power x equals 81, or 3 power x equals 1. Yeah? So what's the x here? 4. And the x here? 0. Now this one I know is a little bit difficult, and I think the difficult part is kind of this step here. So just write it down. Any questions asked? But I think this is the key step here. Do we use both answers? What do you think? Are both answers okay? Yeah, I don't see any problem with them. Yeah. Now I tried to make all these questions have a nice answer here, so it's easy to see what the x is. But in the exam, of course, that doesn't have to happen. So if you had something like this at the end, 3x equals 10, you could use logs. But we'll talk about that in the next lesson. Okay, do you have this? Yeah? Okay. Next one. Okay. 2x power minus 3 over 4 equals 10 power x 9 over 4. Okay, so just check something here. Yeah. Right. Yeah. Alright, so before I even start, what about the x? Can I use any value of x here? What do we think? X can't use 0. X could be any number except 0. Now the reason we can't use 0 is because of this part here. Because x power 3 over 4 with a minus is the same as 1 over x power 3 over 4. And you can see here, definitely x can't be 0. So anyways, I'm just saying, if 0 was our answer, we can't use that answer. It's any number. It could be any number, except we know it shouldn't be 0. Okay. Right. So let's try and solve this one. There's a couple of ways you can do this one. Any ideas on what could be the first step? I can see two first steps. Two things you could do first. Any ideas? Yeah?
Minus 3 over 4.
We could change this into 1 over. Yeah? That's one thing. Anything else?
Multiply
Multiply.
by x 9 over 4. Multiply.
Divide both sides by this, or multiply.
Multiply.
Could multiply. Or multiply by x power 4 as well. In fact, there are many things you can do at the start here to try and simplify this. So, Leon, you suggested putting x power 4 on both sides. So that will at least cancel the 4's in the power. That's one way to do it. Before I do anything with the x's, I kind of want to do something with the 2 and the 10 first. Like 2 can go into both of these. So we might as well divide both sides by 2. So at least I can make it a little bit easier. 5. Okay, so the way I'm going to do it, it's not the only way to do it. I had a few people give me different ideas, which are all fine. But I think the way to get to the answer quickest would be to put a power on both sides. So for example, if I put here like a power minus 4 over 3, minus 4 over 3 power. Because when these multiply, what do you get?
1.
You get 1. So here it's just going to be x power 1, which is just x. Here this will be 5 power minus 4 over 3, and this will be x power, what will that be, 9, well 3 goes into that 3 times, 4 goes into that once, just a minus 3 up here I think. Yeah? Okay, I think the next thing I'll do, maybe a little bit like what Leon had in mind here, I'll multiply both sides by x power 3. So what happens here? They cancel, because it'll be x power 0. So on the left I get x power 4 equals 5 power minus 4 over 3. So there's only one thing left for me to do. What could I do to finish it? What's next? What's the last step? How can I remove this here? Yeah, fourth root. And what's the fourth root as a power?
1 over 4.
Yeah, so I can do a fourth root here, and then this cancels with this. So you're left with 5 power minus 1 over 3 for x, which is not 0, so we can use it. Now, like I said, there's so many different ways to do this. So another thing you could have done at the start, you could have just simply multiplied. You could have said x power minus 3 over 4 over x power 9 over 4 equals 10 over 2, if you multiply them. So this would be x power minus 3 over 4 minus 9 over 4, that equals 5. This would be x power minus 12 over 4, that equals 5. This would be x power minus 3, that equals 5. You could change that into 1 over x cubed, that equals 5. So you could say 1 over 5, that equals x cubed. So then the last step here would be x equals the cube root of 1 over 5, which is exactly the same as that. So again, there are many paths you can take here to the answer. Okay, can I scroll down?
Yeah.
Yeah. Whichever way you want is fine in the exam. Let's see. Okay, so this here, these will make two graphs. So let me draw the first one in red. Where will it cross the y-axis here?
1,
Ah, is it? Where? Come on.
3.
It'll cross it at 3 when you put x is 0. And it will increase like this. This one here, where will it cross in blue? Where will it cross the y-axis? We'll cross it at 4, yeah. And because we're dividing by EX, I think it's coming down. Let me try and draw this. No, it's going up slowly. It's going up slowly. How can I draw this? Something like this going up. Yeah, I think. I'll draw the nice graph in a moment. So anyways, it meets maybe once, maybe twice, I don't know. But it meets anyways. Okay, so how can I find out where they meet? Any ideas? I want to know where they meet, these graphs. Yeah, just make them equal, because they're both equal to y. So let's see what we get if we make them equal. So we have 1 plus 2 power e power x equals 6 minus 2 over e power x. 1 plus 2 e power x equals 6 minus 2 e power minus x, I guess. So if I take things to one side, 2ex plus 2e minus x equals 4. 5. Yes. Okay, next. I could divide by the 2 if I wanted to. I mean, it doesn't go nicely into that, but it makes it a little easier. Ex plus e minus x equals 5 over 2. Okay, now it's getting tricky. So I'll show you what to do next. If you have something like this, you should write it as ex minus 5 over 2 plus 1 over ex. I'll just change it back to that. So maybe somebody can see what to do now. Yeah? Any ideas?
E power x.
That's it. Multiply everything by e power x. So this one will become e power 2x minus 5 over 2 e power x plus 1. Again, what type of problem is this? Quadratic. I don't think this has roots. We'll need to use the formula. So you get ex equals minus b plus or minus the square root b squared minus 4ac all over 2a. So let's see what we get. I got ex equals 2 or ex equals a half. Okay, so I don't want ex. I want x. So if I just go down here, think about it like this. We have e to what power makes 2, and e to what power makes 0.5. So this is exactly what logs are used for. Here, this is log base e of 2. This is log base e of 0.5. So the answer is natural log 2, natural log 0.5. So I think this is like 0.69 and this is minus 0.69, maybe? Yes, about. So these are the two answers for x, which is good because when you look at my picture at the start, I thought there should be a positive and negative x answer. Yeah. Let me draw the nice graph for you. Y equals 1 plus 2 e power x. Y equals 6 minus 2 over e power x. No, sorry, that's not what I want to do. I want to draw the graph. Guys, look up, please. And then we'll draw this one. So yeah, like I thought, there's a negative answer and a positive answer where the two graphs meet. Now, I'm not quite finished because what I haven't done yet is I haven't found the y values, but that's really easy to do. I take my answers for x and I put them back into, say, this one here, 1 plus 2 power ex. So you get, when you put that in, there's x equals that or that, and then y would equal, so if I put that in, that would be a 5. And then if I put minus 0.69 in, I get a 4, I think. So if I look at my graph I drew, that looks like a 5, that looks like a 3, no, I must have done this one, no, I guess I can't do it in my head. Right. Five I got for this. Yes. Yes. You made it back from GNIB. Congratulations. How was it? GNIB was terrible. 5 and 2 are the two values I got for y. If I have a look at my graph, yeah, that looks better. The first one is at 2, and then the second one looks like it's at 5. So the first one here, look, whoops, it's at 2, and the second one is at 5, and this is about minus 0.7, and this one here is also about 0.7. Yeah, about. Okay. Now, before I let you try these, really not certain if you are okay with page 44. Can you just have a look at 44 again? Did you try all of 44? Yeah? Okay. Which was most difficult?
Maybe the last one.
The last one? I don't think the last one was too difficult, was it?
But the same idea as 9 is
Yeah.
quite similar.
What about number 11? How was that one? Oh, sorry, not number 11, sorry, I mean number 10. With the triangles. Yes. I don't know. Should I believe you when you say it was alright? I have some people who are honest. Okay, so which one will I do? I felt that the most difficult one was number 9, I thought. I mean, number 8 was difficult, and I did that one in class with the ball. But I'd like to do number 9. So can you all just read number 9 before I do it? So just have a read of number 9 on page 44. Okay, can we look up? So this is how I'm picturing the problem. So in the world, there, yes? No Snapchat, no whatever it is you're showing them. No laws in class, please, okay, just maths. Um, I'm picturing that there are 1,433 billion barrels, billion barrels, of oil. This year, we will use 30.775 billion barrels. Next year, more is used. Why is that? Why would next year we would use more oil in the world? What might be the economic reason for that?
Economic growth.
Economic growth, yeah. So developing markets would demand more oil next year, right? And then likewise in year 3, there's going to be more oil again. So if the demand didn't increase, and I ask you how long until the oil is gone, well, the answer is just going to be 1433 divided by 30.775. You don't need to write that part down. So for example, so that is 47 years, for example. By the way, I just made these numbers up, okay? I think there's probably more than 47 years left. Anyways, that's not going to be the case. Will it be more or less time than this if it increases? Would it be more? Would the oil run out sooner or later? Sooner. So we need to calculate how long. Now I tell you in the question that this is an increase of 2.5%. So that basically means if you increase by a percentage, it means it is geometric to increase by a percentage. And if you calculate the OR, you might not be surprised to find out that the OR is 1 point, does anyone know?
0.25?
Yeah, 0.25. So likewise it's 1.025. This is the OR. So we need to make an equation here that we can solve. So we know that the year 1 usage plus the year 2 usage plus the year 3 usage all the way up until the last year, that should equal 1433. What type of problem is this? That is Sn should equal 1433 and it's GP1. So the formula is A 1 minus Rn over 1 minus R equals 1433. The A is 30.775 and the R is 1.025 N over 1 point, the same thing, equals 1433. So here, is okay? Our mistake? No? So here we're trying to get the N. So what I'll do is on my calculator, I'll just bring this one, I'll bring this up to the right, and then I'll bring this down underneath. So I'm left with, so this goes up, this one goes down, 1 minus 1.025 power n equals 1433 times 1 minus 1.025 divided by 30.775. So I get minus 1.16409. So what I'll do is I'll bring this one to the right and this one to the left. So I'll get 2.16409 equals 1.025 n. Now, you can use your calculator to get the answer here, because what you want is you're trying to find 1.025 to what power will make 2.16409. So this is what you're looking for. Your calculator has that button. If your calculator doesn't have that button, we'll see in the next class how you can get this by just using ln. But if your calculator has it, we can type it in. 1.025.
Actually, each calculator has n and 10, not 10.
Yeah, but it doesn't have this where you can choose the base. Show me your calculator. Show me. Show me your calculator. Yes, it doesn't have it. 31. 31 years.
What about decimal?
Huh?
The decimal.
Well, did I ask you how many years?
Yeah.
31 years and 3 months, if you want. Now, if your calculator doesn't have this button, that's okay. We'll see problems like this again, and I'll show you how to solve it by just using ln. Okay. Please write this one down if you haven't done it. It's okay, Tony? You did it, or you wrote it down?
No, I did it.
Did you?
There you
Okay. That?
My calculator doesn't have that.
That's okay. That is okay. In the next lesson, I'll show you what you can do, okay? Yeah, how many people actually have the calculator recommended for the course? How good?
Not very good.
It's so expensive, 35.
Yeah, it's 30.
13.
Yeah, but it's worth it. It's worth
It's
it.
a view, like the same function.
No, it has so much more. So much more.
Do you ever use it again, Austin?
What are you going to study next year?
I'm not going to use.
You're not going to study anything next year?
No,
What?
I'm not gonna use
Are you sure? What are you going to study next year?
international relations.
Oh, so much maths. So, you wouldn't believe it. Yeah, you probably won't use it again. What are you doing next year?
Me?
Yeah, well, what are you? Yeah, you were complaining about the price, weren't you? What are you studying next year?
Politics domain.
You'll get
They
good
don't
use.
make it.
You'll get good use out of it. Yeah. And you?
Banking.
Oh, well, you have a super calculator, don't you?
Yeah.
Huh?
Can I use that one?
Yes, you can.
For tomorrow.
Yeah, if you know how to use
Oh
it.
yeah, I know how to use it. Can I use that?
Yes.
Oh yeah.
Yeah, but that's an expensive
Yeah,
calculator.
that's very
Like
expensive.
100, 200.
$100.
Yes. Yeah. So this is a bargain when you compare it, yeah. Okay, so on page 50, let me just tell you which ones to try. Number 1. Yeah. XYZ Number 2, WXY. Number 3, WXY. And then BC, BC.
Six.
No, you don't have to, but
Number one.
6 has something to do with your project.
Oh.
So if you don't do the 6 now, you'll end up doing something like it anyways in your project. So if you want to do it now, you can. Project, yeah.
What's the deadline of the for the project?
I'll tell you in second class. Okay. So can you just try some of these for 5 minutes and then we'll start the next lesson.